Hello everyone. In this video, I'm going to show how to use Kirchoff rule to solve for current. I'm going to discuss PSPM question paper PSPM 2016-2017 question number 2. The figure 2.1 shows a circuit consisting of 2 batteries, 2 resistors and ammeter. If the ammeter has internal resistance of 5 ohm, what is the reading shown by the ammeter? Okay, first we label the internal resistance 5 ohm. 5 ohm we label next to ammeter. The question asks what is the reading shown by the ammeter. Okay, notice that the current that flow through the ammeter is current IA. So we need to find IA. To solve this problem, we cannot use series and parallel method because we have 2 batteries. So to solve this problem, we need to use Kirchoff rule. Kirchoff has 2 rules. The first rule is the junction rule. The sum of current into the junction equals to the sum of current out from junction. So here we need to label the junction. So we have 2 junctions, junction A and junction B. I'm going to choose junction A. At junction A, notice that we have current I1 and IA go into the junction. So sum of I in is I1 plus IA. Meanwhile, the current that out from the junction is current I2. So we rearrange the equation. Because we have 3 unknown variables, I1, IA, and I2, we need to have 3 equations. So this is the first equation. The second equation you are going to get from Kirchoff's second rule. The second rule is the loop rule. According to the loop rule, the sum of voltages around the closed loop equals to 0. So we have 2 loops. We label loop 1 and loop 2. We are going to travel around the loop, so we need to choose the direction that we are going to travel. I'm going to travel in clockwise direction in loop 1 and loop 2. Okay, next for loop 1, we are going to travel in clockwise direction. So suppose we start at point A. So at point A, we travel in clockwise direction. The first component that we get to is battery, because we move from positive to negative terminal, meaning that we are moving from high potential to low potential. Because we are moving from high to low potential, the voltage drop, so we need to use minus sign for voltage drop. So negative 2. -2 for the voltage drop in battery. Next, we continue, travel. In resistor 3 ohm, the voltage in resistor 3 ohm is IR. The current in 3 ohm resistor is I1. So we label I1 because we are moving in the opposite direction to current. As you can see, we are moving downward. Current I1 is upward. Because we are moving in the opposite direction to current, so the voltage will increase. So we use positive sign for voltage increase. Voltage of resistor is I1 times 3 IR. Okay, next, we are moving in resistor 5 ohm. In resistor 5 ohm, the voltage is IA times 5 ohm. Because we are moving in the same direction with the current, so the voltage will drop. Voltage drop minus, so we use minus sign, minus IR IA times 5. Okay, we continue to travel until we complete the loop, until we comes back to our initial point. Because we complete our loop, so we set equals to 0. Okay, I'm going to solve using the mod equation in calculator, so I need to rearrange the equation. Because the first equation, the first variable is I1, and then IA and I2. So in the second equation, I will arrange in the same sequence. The first variable is I1, so we have 3 I1. Second variable must be IA, so minus 5 IA. The third variable is I2. Since we don't have I2, so we just write 0 I2. And then equals to 2. So this is the second equation. Okay, next I'm going to write the equation for loop 2. So in loop 2, I will travel in clockwise direction. Okay, suppose I start at point B. So start from point B, move in clockwise direction. Because I go from high potential to low potential in battery. So the voltage drop in battery is -3. Okay, then I continue to travel. In resistor 2 ohm, I'm going in the opposite direction to current I2. So the voltage will increase. So positive I2 times 2. Okay, next in resistor 5 ohm, okay, I continue travel in resistor 5 ohm. Notice that the direction that we travel is in the opposite direction of current IA. So positive IA times 5. We complete the loop, so set equals to 0. Okay, then we rearrange the equation. I1, we don't have I1, so we write 0 I1. Second variable IA is plus 5 IA. Third variable is I2, 2 I2 equals to 3. Okay, so we already have 3 equation. Okay, so you plug in all the values in the calculator using the mode equation. So I got I1 equals to 0.94A, IA equals to 0.16A, I3 equals to 1.09 ampere. Okay, because the ammeter reads current IA, so IA is 0.16 ampere. The answer is 0.16 ampere. Okay, that's all. Okay, the second question is about potentiometer. The figure 2.2 shows a potentiometer circuit consists of a uniform wire SY of length 100 cm and its resistance 5 ohm. Okay, we take out the information first. So given L, X, Y, 100 cm and resistance RSY is 5 ohm. The EMF of cell A and cell B is 4 volt and 3 volt respectively. Okay, so we label EMF A 4 volt, EMF B 3 volt. The internal resistance of both cells are negligible. Okay, question number 1. What is the length of XP when the galvanometer reading is 0? So we want to find LXP. Okay, a very important concept when the galvanometer reading is 0. The galvanometer reading is 0 is because of V XP and EMF cell B, they are balanced. Okay. So the reading of galvanometer is 0 because V, X, P are balanced by EMF in cell B, 3 volt. Okay, the question asks for LXP. In order to find LXP, we must find the RXP. Okay, here we already have the VXP. We can use the equation potential divider. VXP equals to RXP over R total times V total. Okay. Alright, so the current, if we look at the diagram, the current that comes from the battery, from the cell A, we label as I1. So the current flow from the battery, okay, so I use yellow color. From the battery, it flow along wire SY and back to battery. Okay, so here we have resistant wire RSY in series with cell A. So back to potential divider equation, VXP equals to RXP. RXP we don't have. R total is okay, refer the yellow circuit. Yeah. R total is the RSY. V total is EMF in cell A. Right? Okay, VSP. We know it is equals to EMF cell B 3 volt. 3 volt equals to RXP. We want to find RSY is given 5 ohm times EMF cell A 4 volt. So here we can find RXP. RXP that I get is 3.75 ohm. Okay, RXP. resistance and length, resistance of wire and length, they are directly proportional. So here we can write the ratio Rxp over Rxy equals to Lxp over Lxy. Okay, Rxp 3.75, Rxy is 5 ohm, Lxp we want to find, Lxy is 100. Okay, so we get the Lxp 75 centimeter. Okay, so here is the answer for Lxp 75 centimeter. Okay, for the next part, okay, in the second part, if a 1 ohm resistor is connected in series with cell A, 1 ohm resistor is connected in series with cell A. Okay, so we draw resistor 1 ohm in series with cell A. What is the new balance length XP? So we want to find the new balance length LXP. Okay, when we add 1 ohm resistor to the circuit, it will change the current in the wire. So we need the new balance length or the new resistance RXP to balance the EMF in cell B. So in order to get LXP, we are going to use the same method. We use the potential divider equation. Okay, so VXP equals to RXP, R total times V total. VXP is balanced by 3 volt. Okay, RXP, okay, we refer the yellow circuit, yeah, the yellow circuit. RXP is the new RXP. R total, okay, now R total has changed. R total is now RXY plus 1 ohm. RXY plus 1 ohm. RXY is 5 ohm plus 1. So this is the R total times V total is 4 volt. So we get the new RXP. The new RXP is we get 4.5 ohm. Okay, so using the same method, we write the ratio RXP over the RXY equals to LXP over LXY. RXP over, okay, we go to, okay, RXP over RXY. RXY is 5 ohm. LXP over 100. RSP we already have. RSP is 4.5. We already have 4.5. So finally we get the LXP. The new LXP is 90 centimeter. So this is the new LXP that we need to balance the galvanometer. Okay, that's all. Thank you.